everybody! Today I'm going to be talking to you about scientific notation. Scientific notation is a method for expressing or working with really large or really small numbers. In chemistry we don't like really large or really small numbers, and so this is a way that enables us to work with more manageable numbers without changing their values. It's very important. Just like when we're converting or doing dimensional analysis, we're not changing the value of the number. We're just changing the format in which we write it. This is a shorthand method for writing numbers. It makes calculations a lot easier, especially when we're using a calculator. And now don't worry too much about this if you haven't heard about significant figures yet. That'll be in 2 videos. It's a means of representing a measurement with correct number of significant figures. Significant figures refer to how many digits a number can be written in, and I'll explain that to you later about how we actually figure that out. But if you're reviewing for the quiz or the test, it's a means of representing measurement with correct sig figs. This is how we write scientific notation. We have a coefficient, in this case 5.67 times 10 to the negative 5th. The coefficient is 5.67. We have times 10. 10 is always the base that we use, okay? It's never 5.67 times 8 to an exponent. It's always 10. 10 is our base. And then that 10 is always raised to some exponent. That exponent can be negative or positive, okay? So either or, depending on which way we're moving the decimal when we're writing in scientific notation. My coefficient, notice here, is always between 1 and 10. And the way I've written it here, it can be greater than or equal to 1, but it cannot be equal to 10. It has to be less than 10. So it could be 9.999. It cannot be 10, okay? So it has to be less than 10. So if you look over there at my example here, is 10.2 times 10 to the 4th correct? Is that written in correct scientific notation? Hopefully you notice, no, it's not correct scientific notation because my coefficient here, 10.2, is greater than 10. Okay, so no, because coefficient is greater than 10, and we cannot have a coefficient greater than 10. Everything else is okay. My base is 10, and my exponent, positive or negative, doesn't matter, okay? Now, how do we actually write that number in scientific notation? When we're writing numbers in scientific notation, like I mentioned, we're moving the decimal. We're going to move the decimal a certain number of places in order to get that coefficient, again, between 1 and 10, okay? So if I have my decimal here of 0.0057, I need to move that decimal until it's somewhere in the number so that my coefficient becomes between 1 and 10. Here, now I have 0.057. That's not between 1 and 10. Move it one more place. Now I have 0.57, also not between 1 and 10. One more spot, and that will give me a coefficient of 5.7. So now my coefficient is 5.7. I know that I'm going to have times my base, which is 10. Now I have to figure out what my exponent is. Now, to figure out the exponent, I need to first determine how many places I move the decimal and which direction, okay? I move the decimal 1, 2, 3 places, okay? 3 places. And which direction did I move it? I moved it to the right. Now my key down below tells us whether or not I'm going to have a positive or a negative exponent. I know that this is going to be 3. It's either going to be a positive 3 or a negative. If I move the decimal left, that generates a positive exponent. If I move the decimal right, that generates a negative exponent. Which way did I move it? Now is the exponent going to be positive or negative? I moved it to the right. So I'm going to have a negative exponent. So this is a negative 3, okay? In my example over here, I have 5,620,000, okay? Now notice that there's no decimal. If there's no decimal that you can see, the decimal is implied to be at the very end of the number. So even though you can't see it, our implied decimal is right there at the end of the number. So how many places am I going to move the decimal in which direction? I'm going to move it 1, 2, 3, 4, 5, 6 places until it's between the 5 and the 6. Why does it need to be between the 5 and the 6? Because my coefficient needs to be between 1 and 10. So I have times 10, my base. How many places did I move it? 1, 2, 3, 4, 5, 6. To the left, moving the decimal left generates positive exponent. So 5.62 times 10 to the 6 is correct scientific notation, right? On the other side, 0.00006. I'm going to move my decimal here. 1, 2, 3, 4, 5 places. Okay, I have to move it 5 places, so that's after the 6. And I get 6 times my base of 10 to an exponent of 5. But I move that decimal to the right. Moving right generates a negative exponent. So this is negative 5. All right? Now, what if instead of writing numbers in scientific notation, we want to go the opposite direction? And we want to take numbers that are already in scientific notation and write them in expanded form. We can do that as well. So, how we write scientific notation numbers in expanded form is we have to look at the exponent. Again, we're moving the decimal left or right. We have to look at the exponent to determine, is it a positive exponent? If so, the coefficient is going to get larger. Is it a negative exponent? If so, the coefficient gets smaller, okay? So my example over here, I'm going to write the 9.23 just so we have more room. 10 to the 5th, that's a positive exponent. My coefficient is going to get larger, okay? That means 9.23 is going to be in the thousands, okay? So we're going to move it 5 places to the right to make the coefficient bigger. 1, 2, 3, 4, 5. There's my decimal. These blanks I'm going to fill in with zeros, okay? So now my new number is 923,000. And that's written in correct expanded form. Over here, I have 8.4 times 10 to the negative 4th. We'll write 8.4. Here's my decimal. Now I need to move it 4 places, okay? It's a negative exponent, so my coefficient is going to get smaller. That means it's going to be a decimal with zeros in front of it. So I'm moving this decimal 1, 2, 3, 4 places to the left. I'm going to fill those blanks in with zeros, right? And this number now becomes 0.123084. And that's an expanded form. Now the last thing I want to show you, and we're going to look at this more in class, because it's a lot easier in class, but I want you to have this in your notes. How we do calculator math in scientific notation. It can either be easy or it can be tricky depending on your calculator, unfortunately. Okay, you have to be using a scientific calculator. If your calculator has an EE button, then you're going to use that for the base and the exponent, instead of using times 10. You're not going to type in the x, the times, or the 10 at all. Now, what that EE button looks like, you get out your calculator. I'm pointing to it here. See if you can see it. Now mine is, you have to go to the second power, okay? It's not the x to the negative 1. I don't know if you can see it above there. It's the second and then EE. Some of your calculators will have the EE button be not to the second power, that you can click the button on the calculator. So I would type 9.23 times 10 to the 5 into my calculator as 9 decimal 23 EE 5. There's no times, there's no 10, okay? Just 9.23 EE 5. Option 2, if you don't have that EE button, it's a little more complicated, particularly when we get to division. You're going to use the caret symbol, okay? So look on your calculator, find the caret symbol, or sometimes it's the 10 to the x symbol, 10 to the exponent of x. In this case, you do have to use times 10, okay? You're going to enter the same number in your calculator as 9 decimal 23 times button 10, 1, 0, then caret, you're raising it, the 10 to the exponent of 5, okay? A little more complicated. The important thing is, when you're dividing, if you use option 2, if you're not using the EE button, when you divide, if the denominator is in scientific notation, Doesn't matter about the numerator. If the denominator is in scientific notation, you have to put parentheses around the denominator. It's very important. You'll find that your calculation will be all messed up, and I'll show you why in class, if you don't put parentheses around it. If you're using an EE button, you don't need parentheses ever, okay? If you're using the caret button, parentheses around the denominator. What that will look like is when you type it into your calculator, and you're using the caret button, you're going to put the parentheses there, just around the denominator. That's it for scientific notation. We'll see some practice in class.